Now, you may not know it, but there's a social media site out there called The Facebook, or just Facebook if you're cool. And it's a site where you can post pictures of your vacation or how cute your kids are or whatever. So we did a survey, and when I say we, I mean whatever survey group this was. They did a survey of 1,550 US adults. And of those 1,550, 1,054 said, yes, I use Facebook. I love it. It influenced the person I voted for in the election this year because Facebook is very convincing. So my question is, what percentage of people do you think use Facebook? I surveyed 1,550 and 1,054 said that they used it. That seems high, right? Over 1,000 people out of 1,550. And I'm already getting an answer here in the chat. And the answer that I got is 0.68. I wonder if you could elaborate a little bit on that. Why do you think the answer is 0.68? What'd you do? Or 68%? I like that answer even better. What did you do to get that? I like that answer. Could you explain it, please? How did we get 68%? Ah, very good. So we did some division. We did 1,054 divided by 1,550. This is like a part of a whole. It's just standard fraction. And the answer when you do this, in fact, is 0.68 or 68%. And what this is called is a point estimate. A point estimate is the percentage of people from the group that I surveyed who think, I shouldn't say think, who said yes to the question that I asked them. I asked them, hey, do you use Facebook? 68% said yes. So the symbol that we use for a point estimate is P with a little arrow on top. Have you seen that symbol before? The way that you say this out loud is P hat. And the way that you find that is the part, which is the number of successes you have. And I know you can't see me, but I'm putting successes in air quotes. Success, meaning people who answered yes to my question, over N, which is the number of people that I surveyed. So I'm going to say that this is successes over trials. And the way that you would say that in English is people who said yes over people I asked. So I asked 1,550 people, do you use Facebook? And 1,054 of them said, yes, I use Facebook. And the statistical variable that we use is called P hat. Okay. So 68% of the people that I asked said, yes, they use Facebook. Does that tell me that 68% of people use Facebook? Not just people that I ask, all the people. Do 68% of people use Facebook? And the first answer that I got in chat is no. No, it is not what that tells me. But if my 1,550 people are representative of all people, meaning if I randomly selected a group of people, so I didn't survey 1,550 people all in the same town, for example. I randomly got people all over the world, 1,550 of them, and asked them, and 68% of those people said, yes, I use Facebook, then I think it would be reasonable for me to assume that about 68% of everybody uses Facebook. Now, you answered no when I asked, do 68% of people use Facebook? And that's a correct answer. The answer is no. That does not mean 68% of people use Facebook, but it does mean that about 68% of people use Facebook. About 68%. Could be a little bit more, could be a little bit less. And the little bit more or less that it could be is a term that you will definitely hear if you turn on the TV when class is over and watch the election returns. And that is called margin of error. Tonight being the presidential election, if you turn on the news, you are definitely going to hear the phrase margin of error. They will say things like, candidate A has 52% of the vote in Texas with a margin of error of 3%. Or sometimes they'll get real sneaky and they'll say like plus or minus 3%. So when we talk about the phrase margin of error, what we mean is, I think my answer is probably pretty close to 68%. 68% of the people I surveyed said yes. So I think if I were to ask everybody on Earth, 68% of them would also probably say yes, about. The margin of error is, how close to 68% am I? So let's say, just for example, I'm going to make up a number here. For example, let's say my margin of error is, let's say 3%. Say 3% of my margin of error. What I would do is I would take that 68% point estimate and I would subtract 3% from it. 68% minus 3% is 65%. So I would go 3% below my point estimate. And then I would also go 3% above my point estimate. That would give me 71%. And I would say between 65% and 71% of people use Facebook. That's what margin of error means. Margin of error means, okay, it's probably not exactly 68%. That would be crazy if it was exactly 68 for everybody on Earth. But it'd be reasonable to say that if I did go out and ask all 7.5 or 8 billion people on Earth, however many we have now, that between 65 and 71% would say that they use Facebook. That would be a reasonable thing for me to say. Again, I am assuming that the 1,550 people that I selected are people from all over the world chosen at random. If I survey 1,550 people in Marble Falls, Texas, I don't think it's reasonable for me to say that Marble Falls, Texas represents the entire world. But if I got like 100 people from the United States and then maybe like 200 people from China, and then I got like 75 people from Russia, you know, like I got people from all the countries all over the world and I got 68%, it'd probably be reasonable for me to say if I asked everybody, it'd be 68%. This is such an important thing for you to understand in statistics because there is no way for me to go ask every single person on Earth. That would be bonkers for me to go ask every single person. By the time I finished asking every single person, some of the people I asked would be dead, and some of the people that were not alive when I started asking would have been born. There's no way for me to ask every single person on Earth. So in statistics, what we do is we ask just a handful of people, a handful of properly selected people, random selection. We ask a handful of people and we say, well, if this is what a handful of people think, I can have not a perfect answer, but a pretty good guess of what everybody would say if I had time to go ask them all. So the next question is, I forgot to turn off my notifications there. The next question is, how do I find margin of error? If the margin of error is the magic number that tells me how close my estimate, my point estimate is to the truth, how do I find margin of error? So we're going to use E for margin of error, and then margin of error equals critical Z multiplied by p hat times q hat over n. And I want you to go ahead and write that down real quick, and then I'm going to define what each one of those variables mean for you. Go ahead and write that down, and then I'll tell you what each variable means. So E is the margin of error. You learned about critical Z last week, I hope. If you didn't, we're going to go over it. Ugh. If you didn't, we're going to go over it here in just a minute. I'm going to review you on critical. Once I learn how to write, I'm going to review you on critical Z. Critical Z. P hat we just talked about. That's our point estimate. And the way that we defined a point estimate was the proportion who said yes. Our next variable is Q hat. That is the, we could define that as 1 minus P hat, but what it really is the proportion who didn't say yes. And before you ask me, the proportion who did not say yes and the proportion who said no is not the same thing. If I said, do you use Facebook? Some people said yes. Some people said no, but some people might have said something besides yes or no. They might have said, I don't know, what's Facebook? That's not a yes or a no. They just don't know what it is. So it's the proportion of people who didn't say yes. So that includes the no's, but it also includes people who said anything other than yes. People who said, I don't know, for example. N is the number surveyed. Okay, so to find the margin of error for this problem, here's what I would do. I would say the margin of error is equal to my critical Z times, and then P hat, my point estimate was 0.68. Q hat was 1 minus P hat. You could do 1 minus 0.68, or you could write 0.32, which is what 1 minus 0.68 is. And on the bottom is the number of people I asked, which was 1,550. Now we almost have enough information to figure out the margin of error. As a matter of fact, we're really only missing one thing, only one number missing to figure out what the margin of error is, and that is this critical Z here. What is the value of critical Z? And the answer, as you should have learned last Thursday, I hope, is that it depends on how confident you want to be in your answer. How sure do you want to be about your answer? And to illustrate that point, I would like to introduce you to the worst weatherman of all time. The worst weatherman in the history of weathermen. Are you ready to meet him? Okay, here he is. Here's the worst weatherman of all time. He comes on the news in the evening and the anchor says, let's go to Chuck to see what the weather's going to be like this weekend. And Chuck says, well, I can tell you, I am 99% sure that the weather this weekend is going to be between negative 100 degrees and positive 150 degrees. Yes, folks, you can count on that. The temperature will be somewhere between negative 100 and positive 150. I'd stake my life on it. Now, Chuck is technically right. The temperature this weekend is probably going to be between negative 100 and positive 150. But I would not say that that answer is incredibly useful. Knowing that either the temperature is going to be so cold I will die of hypothermia, or so hot I will die from heat stroke, or anywhere in between, not incredibly useful, Chuck. Chuck, I need a better estimate from you than negative 100 to positive 150. I know you're super sure that you're right, Chuck. You're really, really sure that the temperature is going to be between those two numbers. Congratulations, but that's not super helpful to me. Could you give me a better estimate? And Chuck comes back and says, well, as a matter of fact, I can. I think that the temperature tomorrow is going to be between 70 degrees and 73 degrees. And you're like, wow, 70 to 73? That's a pretty specific estimate, Chuck. How sure are you that you were right? And Chuck goes, I'm 1% sure. Like, okay, so you've given me a really, really specific temperature for tomorrow, Chuck the weatherman, but you don't seem like you're super sure about your answer. Like between 70 and 73 is great, but if you're only 1% sure, that's not useful to me. I need you to be pretty sure, Chuck. I need you to be pretty sure that you're right, and I need you to give me an estimate that is useful to me. Should I wear shorts or pants tomorrow, and how sure are you? So this is where a confidence interval comes in. I can be really, really, really sure that my answer is right, but I'm going to be giving you a big, big range of numbers. I'm really, really sure that the temperature tomorrow is going to be between 0 and 100. Or I can do the opposite, which is that I can be really, really confident of my answer. Really, really not confident of my answer. I'm only 2% sure that I'm right, but the interval's teeny, teeny, tiny. It's going to be between 70 and 73. I am 2% confident. Obviously, both of those are extremes. I want something that's kind of in the middle. I want to be pretty sure of my answer without giving an enormous range of numbers. So that is when I construct a confidence interval. A really good idea for a confidence interval is instead of being 100% sure, or instead of being 2% sure, what if I was like 90% sure or 95% sure? That would be such a great compromise. If you're 90% sure means you might be wrong, but probably you're right. Probably you're right. I can live with that. I can live with probably I'm right. So here are the steps you need to do to construct a confidence interval. By the way, I'm trying not to get my feelings hurt that my whole family just came home and my son and my wife came in and gave me a kiss and said hello, and my daughter is nowhere to be found. So step one is you want to identify the sample statistics. Now, what I mean by that is the two numbers you want are N and X. N is the number of people that I surveyed, and X, I hope you remember, because I said it 3 minutes ago, is the number of people who said yes. Step number 2 is to find the point estimate. That is P hat, and you find it by doing X over N. Okay, now step number 3 is going to seem a little silly, but it's super, super important. Whenever we find critical Z, and this is something that you learned on Thursday, when we find critical Z, what you are doing when you use a Z-score is you are assuming that your data is normal. You are assuming that it follows the normal distribution. So before I can go any farther with this confidence interval, I have to make sure that it's okay for me to use a normal distribution. So step 3 is to verify that the sampling distribution of P hat can be approximated by a normal distribution. Now, how can we make sure that our sample is big enough for us to use a normal distribution? It's a pretty simple hurdle to clear. All you have to do is make sure that your number of successes, meaning the number of people who said yes, and the number of people who said no, is at least 5. So the number of people times p hat is greater than 5, and the number of people times q hat is greater than or equal to 5. So what this means in English is at least 5 people said yes, and at least 5 people said, can't spell again, said no. After we verify it's okay for us to use the normal model, now that we know it's okay for us to use the normal model, the next thing we have to do is find the critical value. So step 4 is find the critical value, which was, we did z sub c, that was our variable we used, that corresponds to the given level of confidence. We're going to get to that in just a minute. And then after we know all that stuff, we know that it's normal, which means we can use the critical value. We know the number of people who said yes, we know the number of people who said no, and we know the total number of people we asked. Now we can find the margin of error. And the formula that we did for margin of error was E equals critical value. The only part of this you should really be confused on right now is critical value. That's the only part I haven't gotten to yet. Everything else you should feel reasonably okay about. If you don't know critical value, it's cool. And then the last step is build the confidence interval. And if I'm writing too fast for you, calm down. I promise I will send you these notes when I'm done. And the way that you build the confidence interval is it's p hat minus the margin of error to p hat plus the margin of error. Lordy. Now, hopefully you have been in this statistics class long enough to realize that we are absolutely not going to do all of this math. I want you to understand what is happening, but we are definitely not going to whip out our pencil and paper and our slide rules and actually do this math. In fact, we're not even going to go really find the critical value. Instead, we are going to use statistics software to do that for us. Now, if we had like a graphing calculator, like a TI-84 or a TI Inspire, those will do it for us. But our favorite website we use for statistics, StatCrunch, will also do it for us. And so let me give you a question. We are going to find a 95% confidence interval for the proportion of people who use Facebook. Who uses Facebook? Let's go find out. So from the math that we did up at the top, we know that the number of people we surveyed was 1,550. And we know that the number of people who said, yes, I use Facebook was, I already forgot, let me scroll back up, was 1,054. Okay. And we did the proportion p hat, and we found out that that was 68%, which means that q hat was 32. 1 minus 0.68 is 0.32. So what our confidence interval would look like if we were to write it out would be p hat plus or minus the critical z times the square root of p hat q hat over n. So let's plug in our numbers. It's 0.68 plus or minus critical z times 0.68, 0.32 over 1550. That's what it looks like before I actually do any math stuff. I need to find critical Z for 95%. Now, you don't need to write this down because we're going to have software do it for us. But in case you were curious, the critical Z for 95% is 1.96. You don't really need to write that down. The software is going to do it for you. But you can find that by looking it up on your Z-score chart, which is in the, if you have the textbook, it's in the back of the textbook. And if you don't have the textbook, you just Google Z-score chart and it'll tell you what it is. But we, as children of the Lord, are going to use StatCrunch. So if you have it open, if you have a browser open, I would, if I were you, go ahead and open up StatCrunch. Get it open on my end, and I'll share it with you. There we go. So what we're going to do in StatCrunch is we're going to click on Stat. And we're going to go down to Z-Stats and select one sample with summary. Now, there are two things that we would select here. One is with data and one is with summary. With data is when the problem gives you a list of numbers. We're not really going to do that right now because we're talking about proportions. We don't have numbers. We have people who said yes or no. So we're going to do with summary on pretty much all of these problems. Oh, that's eyeball. I'm going to do a confidence interval. Oh, hold on. I might have clicked the wrong thing. Oh, yeah, there we go. Sorry, I did click the wrong thing. It's stat proportion stats, one sample. Sorry, I clicked on Z-stats. That's for hypothesis tests. My apologies, did not mean to confuse you. It's stat proportion stats, one sample, and we're going to do with summary. Okay, so number of successes means how many people said yes? Well, 1,054 people said, yes, I use Facebook. Number of observations means how many people did I ask this question to? I asked 1,550. And then it's asking me to perform a hypothesis test, or if you click the second radio button, it's a confidence interval. We will get into hypothesis tests later on in the semester, but right now we're just going to do confidence intervals. I have to confess to you, method is not something I've seen before. Agresti, cool, or standard? Well, we're just going to do standard. I've never heard of agresti. That's kind of cool. Okay, and then we're going to go ahead and go to compute. So you can see right here, it calculates a couple of statistics that we think are really valuable. One is that it gives us the sample, that sample prop 0.68. That should seem familiar to you. That was the proportion that we got for ourselves whenever we did the 1054 divided by 1550. We got a sample proportion of 0.68. That was our p hat. If you look next to that, you can see the standard error, 0.011848506. That's the part of the problem that started with the critical z and was multiplied by the square root. L limit and U limit are the lower limit and the upper limit, meaning those are the two numbers that create our confidence interval, 0.6568, we'll call it, and 0.7032. So whenever I am writing that for my answer, I'm going to say for my work, StatCrunch, I did StatCrunch to do the work. And my interval here, my lower limit and upper limit was I'm just going to round to 4 decimals. So I'm going to do 6568 to 7032. Or if you want to write this in percents, you could say it is from 65.68% to 70.32%. So what we could say is I am 95% confident that the true proportion of people Facebook is between 65.68% and 70.32%. And that is probably your very first confidence interval. I'm going to assume that you have not done a confidence interval before, so that would be your first. So most of what you have to do is be able to read the problem and pull out the important numbers, which for our purposes was how confident are you? And then what was the number of successes and the number of people that you asked? Now, of course, we're going to practice this a couple more times. I'm going to give you a couple more of these problems so that you can get used to them. But for right now, do you have any questions? If your question is, my God, I don't get it, what have you done? Just relax. We're going to do a couple more. But do you have any questions about that specific problem? What you should notice is that whenever we use the software, the only 3 things we really had to know was X, N, and how confident you were. How many people said yes? How many people did we ask? and how confident were we in our answer. 95% confident is pretty confident. If I said I'm 95% confident you're going to die if you walk outside, you'd probably stay inside all day. So the question is it always going to be 95%? And the answer is no. But in StatCrunch, there's a way to adjust the percent confidence you are. Usually, I suppose if somebody wanted to be weird, they could do like, I want you to be 87.3% confident. That would be bizarre. The most common ones are 90, 95, and 98. And there's a give and take there. Remember our incredibly terrible weatherman. The more confident you are, the bigger the range is going to be. We will have a wider range of numbers if we're really, really confident. If we're willing to reduce our confidence, like instead of only being 95% confident, what if I was 90% confident? If I'm willing to reduce my confidence level, then I can shorten my interval. So like instead of 65 to 70%, maybe it would be 66 to 69%. Maybe I can make a smaller interval if I'm willing to be less confident. 95% confident is I'm pretty sure. If I'm willing to go from I'm pretty sure to I'm kind of sure, then I can give you a more specific answer. But the trade-off is I'm going to be less sure about how good my answer is. Okay. Go ask your mommy, sweetheart. I bet your mommy will open it for you. I'm so popular here. Okay, that was a good question. Anybody else have a question? Is it always going to be 95% is a good question? Anybody else have an incredibly intelligent question for me? Or an incredibly stupid question? I'll take those too. Okay. So I asked 800 US adults between the ages of 18 and 29, how do you get your news? Do you get it online, television, radio, or do you read the newspaper, Grandpa? And surprise, surprise, half of them say they get it online. And then 27% of them get it on television. 14% said radio. 50% said, what's a radio? 5% said print newspapers, and 90% said, what is a newspaper? So the question is, who gets their news from the television? My guess is 27%. 27% of my sample was 800 people. My guess is that 27% get their news from television. But it's probably not exactly 27%. It's probably close to 27%, but maybe not exactly. Okay, so let's go back up to our steps here. Step number 1, identify N and X. So that's what I'm going to do first. N and X. What was the number of people that I asked? That part's easy. How many people did I give the survey to? I mean, it says right there from a survey of 800 US adults. So I'm 800 for N. And the next question is X, how many people said yes? This one actually requires me to do a little bit of math. I don't know how many people said yes. I know 27% said yes, but how many people is 27%? So I will take the 800 that I asked, and I will multiply by 27%. And 800 times 0.27 is 216. So the number of successes I have, or the number of people who said, yes, I get my news from the television, is 216. All right. Step number 2. Find the point estimate, which is X divided by N. That part's actually easy. The problem gives it to me. The problem says 27% of people said television. So I already know the point estimate is 0.27. That's pretty simple. Okay, step number 3 is make sure I can use the normal model. It says verify that the sampling distribution can be approximated by a normal model. How do I do that? At least 5 said yes, and at least 5 said no. N times P hat is at least 5, N times Q hat is at least 5. So I gotta make sure that both of those are at least 5. So let's go back down. Well, I know that N times P hat is at least 5 because I already did it. It was 800 people times 27%. That was 216. That is greater than or equal to 5. And the other one is N times Q hat. That would be 800 times 0.73. And according to my calculator, that is 584. That is also at least 5. As it turns out. Now, the next step is to find the critical value, find the margin of error, and then construct the confidence interval. Those 3 steps are all going to be done using StatCrunch. So I'm going to go back to StatCrunch. I'm going to go ahead and close this window from last time. And I'm going to go stat, proportion stats, and then one sample with summary. Again, with data is whenever I give you a big long list of numbers. We're not really going to be doing that today. We're going to do with summary. So how many successes did I have? Well, according to my math, I had 216 successes. Number of observations means how many people did I ask? I asked 800 people. I don't want to do a hypothesis test. I want to do a confidence interval. Now this says 0.95, which is 95%, but this question that we got was 99% confident. So I'm going to change this to 0.99. I'm going to leave the method as standard, and then I'm going to do compute. This gives me the standard error, which is 0.0157 if we round it. And it also gives me the lower limit and the upper limit, which is the part I'm concerned about. The lower limit is let's say 2296 if I round it. And the upper limit is 0.3104. So what I could say here is I am 99% confident that the proportion of people who get their news from television is between 22.96% and 31.04%. And when I say true proportion, what I mean is if I asked everybody, the true proportion of us is 18 to 29-year-olds. (18 to 29-year-olds) who get their news from television. Is between, and I'm just going to write the percent, 22.96% and 31.04%. What questions do you have on that problem? So the last thing that you need to know about finding confidence intervals is an usual idea how many people I need to survey. Every time I've given you the number, one was 800. Usually I don't know how many people it is. So what if I need to know how many people to survey? That's minimum sample size. I'm going to go out and I'm going to ask some people, how many people should I ask? And I'm just going to go ahead and give you the formula here. The number of people equals p hat times q hat times the critical value over over e, margin of error, squared. If n is not a whole number, you have to round up to the nearest whole number because you cannot survey part of a person. As it turns out, cannot survey part of a person. Now, another important thing to note here is if you don't know p hat and q hat, use 50-50. If you have no idea. Usually you don't. Usually you have no idea. You don't know what people are going to say until you ask them. Okay, so let me give you an example. Let's say, just because it's election night, that you're running a political campaign. And you want to know who's going to vote for your guy. You need your estimate to be accurate within 3%. What that means is you need a margin of error of 3%. How many people should you survey to make sure that you get an accurate result of who's going to vote for your candidate? Well, if no preliminary estimate is available, we have to use 50-50. So it's going to be n equals 50-50 times the critical value. I want to be 95% confident. I told you that was 1.96 over E, the margin of error. Well, I want to be within 3%, so 0.03 squared. So I'm going to go ahead and get out my calculator. And I'm going to do this math. 1.96 divided by 0.03 squared. And I got 1,067.1111. Now, if it's not a whole number, I got to round it up. So it's 1,068. So in order for me to get an accurate estimate, I'm going to need to survey at least 1,068 people. Oh, hi, Paige. Welcome. I'm glad you're here. Andy says, so ZC will always be 1.96. ZC will always be 1.96 if I am 95% confident. If I am not 95% confident, it will be a different number. So 95% ZC is 1.96. If it's 90%, ZC is 1.645. And I'm going to be honest with you, I don't remember any others. Those are the two most common. I think 99% is 2.023, but I'm going to put a question mark next to this one because I'm not 100% sure. But 90 and 95 are without a doubt the most common. Now, the second part of the question says, what if your preliminary estimate gives you p hat equals 0.31? So that would be exactly the same scenario, except if p is 0.31, then q would be 0.69. Everything else will be the same. So again, I'm going to get my calculator. If I can find one. Get my calculator. And my calculator says 913.0203, which we would have to say is 914. We have to round up to the nearest whole number. And so if I was running a political campaign and I wanted to know how many people are going to vote, how many people do I need to survey to find out how my candidate's doing, then I would need to survey 1,068 people if I had no idea how people were going to vote. But if I did have an idea of how people were going to vote, and I thought that 31% were going to vote for my candidate, I would need 914 total vote or total surveys in order to tell who was going to vote for my candidate. That's the number I would need.